In this video, we're going to take a look at some applications of distributive property as far as everyday math. And then we're also going to take a look at a couple other factoring ideas. So let's go to the applications first to try to just get some more practice on the distributive property. So if you notice, sometimes we have things like, we want to take 25 and we want to multiply that by 60. We're like, wow, that's tough. Okay, well, let's try to take a look at it and see if we can do this a little easier. Instead of thinking of 25 as 25, let's split it up. Let's think of it as 60 times 20 plus 5. Now the distributive property can be used. So if we distribute that 60, we can almost do this in our head. 6 times 2 is 12, but I have 2 zeros, so I need 2 zeros. Plus, 6 times 5 is 30, but I have an extra 0, so I need an extra 0. Well, 1200 and 300 is 1500. And that's something that you might have been able to do in your head. So let's take a look at another one. Sometimes they get a little tough to do in your head, but we'll take 27 times 34. And you think, well, wait a minute, that's really, really tough. Yeah, but we can kind of do it a little differently. And so we can use some things that we might remember. All right, so let's split this up, but instead of saying 27 or 20 plus 7 times 34, let's take it as 27 times 30 plus 4. You say, well, wait a minute, that's really hard. Yeah, it can be. But 27 is 9 times 3. So in my head, I've got 9 times 3. But I'm multiplying it by 3. So I say times 3. But this is 9. 9 times 9 is 81. So 3 times 27 is 81, and then 0 makes it 810. You say, I wouldn't have thought to do that. Well, it takes experience. And this isn't necessarily the best way. It's just a way. It's one of the ways I use to try to keep this stuff in my head. And so now I go to 27 and 4, except I'm not going to multiply 27 by 4 because that's tough. I'm instead going to probably look at it this way. 27 times 2 times 2. 27 times 2 is not that bad. It's 54. If I multiply 54 by 2, I get 108. So this is really 810 plus 108. This is equal to 918. So 27 times 34 is 918. You might think, well, that's not very easy at all. Well, what's the alternative? By the way, this kind of gives you a hint as to why, when we multiply these things like this, we do this. 7 and 4 is 28. Carry the 2. 7 times 3 is 21, and 2 is 23. Bring down a 0. You might say, well, how does that tell us? Look at what you're multiplying. A tens and a tens. You're not going to get any ones out of that. That's why you put the 0 there. So 4 times 20 is actually 80. 20 times 30 is actually 600. And you still get your 918. So there's really kind of a hidden structure behind here. So don't necessarily just poo-poo it. Try it. See what happens. Sometimes it'll work for you. Sometimes it won't. It's okay. That's all right. All right, so there's everyday math that you can use distributive property with. Now, back for factoring. Remember, factoring is just simply using distributive property in reverse. And so it's not really that different. But one of the things that we should probably mention is that if you have something like negative 4x plus 2, and you want to factor that, it is conventional. It is not necessarily more or less correct, but it is conventional that if we have a leading term, that leading term is the one out front, that has a negative coefficient, and we are going to factor, we factor out a negative. Well, what I'm going to do is just give you a hint on how to work around this. If you see a negative out front, put a negative out front. Now look at the numbers, 4 and 2. What is the greatest common factor that they have? Well, 4 has 1 and 4, and 2 and 2. 2 has 1 and 2. 2 is the greatest common factor, so we pull a 2. And we throw down some parentheses, and now we divide. Negative 4 divided by negative 2 is a positive 2x. A positive 2 divided by a negative 2 is a negative 1. And you're done. That's all the harder it has to be. But keep in mind that if there is a lead term that has a negative coefficient, this number in front of the variable, it's called a coefficient. If it has a negative coefficient, you must, by convention, bring that negative out. It's not wrong if you leave it in, but most of the time it's going to be more helpful if you bring it out to begin with. Hope that helps you.